Ladies and gentlemen, it is 4 o'clock Eastern on a Tuesday, which means it must be time once again for the briefing room. Yes, indeed, my name is Eric Cavanaugh. I will be your humble, excitable host for another episode in our wonderful show here. The briefing room is halfway through year number 6. Time flies when you're having fun. Well, folks, the topic today is predictive insights, turning machine data into intelligent action. This is obviously a very hot topic these days. We're learning more and more about big data, and in particular machine data, as we do these events, and it's a game changer. It really is opening a lot of doors for people and creating new ways of getting things done, and we'll talk about all that today in the show. So there's a slide about yours truly. Hit me up on the Twitter if you're one of those types. We'd like to tweet about the show using a hashtag of BriefR. So as many of you now know, the mission of the briefing room is to reveal the essential characteristics of enterprise software. We do that by pairing innovative vendors with independent analysts, and they take live briefings right before a virtual studio audience. Just think of like your old fun TV shows from years gone by. We have a virtual audience. You are a big part of the show today, so please don't be shy. Send your questions in at any time. We'll queue them up for the last 10 minutes or so of the program. So we do different topics each month, and that's partially for the benefit of the audience, just to group like technologies together. But we do have the occasional catch-all month for topics that maybe couldn't fit into one of the usual categories. So it's an innovators month this month. So we're talking to all kinds of different companies doing really cool, interesting stuff. So let's talk about machines. This is one of my favorite quotes. That's our good buddy Elon Musk, of course. Many of you have heard of him, very famous guy these days. And he keeps talking about, oh, the machines are going to take over and we should be scared and blah, blah, blah. Well, I disagree. I don't think the machines are going to take over. I do, in fact, love machines for all kinds of reasons, one of which because machines don't lie. If you think about traditional business intelligence and data warehousing and a lot of the predictive analytics that was done in the past 20 years or so, well, a fair amount of that data includes guesstimates, includes bad data, includes mistakes. And if you talk about doing predictive analytics, you know, small errors can propagate very quickly and cause some pretty big problems down the road. So if you're going to do predictive analytics, you want to make especially sure that your data is clean, that it's accurate, and that's the nice thing about machine data is, yes, people do have to program machines. Mistakes can be made there, and there are changes that are made to log files and the nature of log files and how they look. That stuff happens, but you don't really have as much of a problem of people intentionally giving false information because machines don't lie. So I think this is a really interesting step forward in the whole area of predictive, because by using machine-generated data, you can create all kinds of interesting perspectives on what's happening. And you can take a look, for example, at, log files for different mobile devices, or log files for manufacturing equipment, or log files for any kinds of equipment that is getting stuff done, like cloud infrastructure, for example. If you think about the amount of money that big companies lose when different parts of their infrastructure go down, it becomes very obvious the value in being able to understand when something is going to break or when something is going to happen. This has actually been taking place for probably over 20 or 25 years in the manufacturing space, especially with very expensive things like planes, for example. So it's not new, but now there's so much more data available. The tools are so much more sophisticated in terms of being able to use that data, and that's all coming together very nicely in this world of predictive analytics. So I'm a huge fan of machines. I love this whole concept of machine learning. I think that the term gets misunderstood because it sounds like machines are learning how to write poetry and they'll steal your wife away with some beautiful poem. Well, that's not going to happen. So we don't have to worry about the darker, crazier things that guys like Elon and some others have been talking about these days. I'm not concerned about that at all. I think it's going to be just fine. So we do have our very own Dr. Robin Bloor in the briefing room today. It's always nice to have him. And we have Prediction. So Prediction software, as the name would suggest, focuses on analytics and predictive analytics in particular. These guys have been doing well for a number of years now, so we're very pleased to have them on the call because they're going to show us some interesting stuff about what's going on at Prediction. So Steve Stover is on the line today. You can see he's a successful product and technology leader with 20 years of experience in big data and analytics, cloud, and so forth. He's going to be showing us some information right about now. So with that, Steve, actually, I'm going to go ahead and pass it over to you. I would suggest that you go ahead and share your desktop and take it away. The floor is yours.
Great. Thank you, Eric. So hopefully my screen is now presenting. So great. Thank you. So thanks, everyone, for joining the session today. So first, let me give you a little bit of background, go a little bit deeper than what Eric just talked about. So we've been around for quite some time. We were founded back in 2009. We have our headquarters in Southern California. I am actually today in our Redmond office. One of our co-founders and our CTO, who has a rich history with Microsoft and their analytics group and has built a great team here in Redmond. So we do have an engineering presence in the Redmond, Washington area. We're fortunate to have quite a number of great strategic investors like GE, EMC, and Accenture. Most recently, we announced a new strategic investor coming on to join us in Software AG. We do have a lot of great talent here, including expert services teams with people who are well-versed in data science and statistics and related fields. We also have a great set of technology and go-to-market partnerships as well. Luckily, a number of our strategic investors also happen to be very strategic partners for us, like Accenture. We have been working with Accenture very closely over the last several years in the areas of health and life sciences. More recently, we've started to work with them on including our technology into their product for an IoT platform called the Distributed Connected Products Platform. Software AG, again, one of our strategic investors as well as a valued partner. You'll start to see a lot more coming out from both companies in terms of combining our offers and providing predictive analytics in a streaming context, particularly, again, well-suited for the IoT. We have a number of partnerships across multiple industries, which includes Microsoft. Microsoft has been a very long-term partner, very good to work with us. Very recently, we have focused on a joint go-to-market partnership to open up the Asia-Pacific region to bring health and life sciences use cases to that market. In addition, we work with premier platform providers within the IoT, like ThingWorx as well as Flat One. And there's a swath of other partners that we have here as well. Along with those great partnerships, of course, come a set of great customers. As Eric mentioned, we have been focused in predictive analytics for some time, so we are fortunate to have quite a few customers across multiple industries, like technology with Cisco. One of our longtime and one of our best customers, Carolina Health Systems, from the healthcare provider customer and vertical segment, along with public sector with the U.S. Air Force, travel and hospitality. So a great set of customers and partners addressing multiple industries. Along with that, we've been generating a lot of buzz in the market recently from an industry recognition perspective. We were really happy to debut on the Magic Quadrant this year for advanced analytics. We got one of the most favorable ratings of any new entrant onto the quadrant. So we're really proud of that accomplishment. Similarly, we debuted on the Forrester Wave for Big Data Predictive Analytics. Most recently had a discussion with the Hurwitz team on a webinar, but they've recently recognized us as a challenger in the advanced analytics market. Perhaps not surprisingly, because of our focus in healthcare, Research and Markets named us the key player in healthcare analytics market. Again, just a great set of industry recognition that's very reflective of the market momentum we've been having as of late. So to expand a little bit on the topic around the IoT, there's been a lot of discussion about the IoT, lots of buzzwords, lots of numbers being thrown around. But what we're interested in at Predixion is really making sense out of all that data. And there's a lot of data being generated, and there's a lot of reasons why. So the cost of the things that power the IoT or make it useful around processing costs or bandwidth costs have come down precipitously over the last 10 years to the tune of about 40 times to 60 times, which is really leading to what is feeding all of these big device numbers we hear across the industries and a number of the analysts talking about. And up to 50 billion devices connected by the year 2020. what's enabling that to happen is that cost of bandwidth to generate that data, and sensors and smart devices in terms of the processing cost brings that cost down, which leads to a big deluge of data coming from IoT devices to the tune of about 4,400 exabytes. I like to talk about this number a lot because 4,400 exabytes by the year 2020, big number, but the way to think of it to make it a little bit more real is that's really 4,400 billion terabytes. Just a tremendous amount of data that's being generated from the IoT and presents an opportunity for a lot of our customers. Now, with all of the talk in the industry is really about getting connected and collecting data. That's really a lot what you hear in the news today. But we do think the true value of the IoT will be realized when you can make significant business changes from the insight provided by analytics of all this IoT data that we just talked about. And when we speak with our customers, several common themes come across regardless of industry. Issues such as understanding and forecasting utilization, consumption, and demand to better match required capacity with fluctuations. This can do things like help you optimize your supply chain, only to stock and ship parts based on when it's actually needed. If you have a large set of geographically distributed assets in the field, being able to cluster maintenance and repairs when you actually need them provides a big cost savings. The clustering service helps you save time and money by sending field resources once to service multiple assets versus going out multiple times and servicing those assets individually. In many ways, what I just talked about can help better provide enhanced customer experiences, but also leveraging things like beacon technology and even mobile applications in retail and opportunity for us within the IoT. Opportunities are also emerging from the roots of digitizing healthcare and the industry embracing the IoT. Leveraging remote monitoring devices, predictive analytics can be applied to the optimization of treatment plans based on improving or worsening patient conditions. That way, healthcare providers can scale back treatment and monitoring relative to the probability of improving conditions, or to intervene with increased telemonitoring or scheduling inpatient appointments based on the risk of worsening conditions. This leads to reduction of costs and improved quality of care. Another element of cost savings is preserving the value or extending the remaining useful life of large expensive assets like the planes that Eric mentioned by avoiding downtime. We can do this by predicting component and system level failures before they occur or turn into cascading failures when an issue that might seem small at a component level can turn into a very big and expensive issue down the line with a cascading failure. The way to achieve this goal is by providing automated actions in real time on the device itself. You get to save money by squeaking out as much as you can from that large expensive asset and by performing maintenance when you really need it or preventing compounding damage to your asset before those failures actually occur. This is in comparison to doing these things in a reactionary mode based on metrics such as mileage or hourly operation without consideration of the operating conditions or measured integrity of the components or the system itself. Last but not least, our customers are just beginning to tap the potential of all that data that's really getting generated from the IoT, and they often turn to us to help them identify new product or business opportunities by analyzing all this great IoT data. Given all the opportunities for predictive analytics in the IoT, we're really focused on several industries and use cases. As Eric mentioned, the end-to-end sort of beginnings of where the IoT really started had its roots in manufacturing, and it's not surprising perhaps that we're really focused on industrial verticals such as manufacturing, energy, utilities, as well as transportation. There are more horizontal use cases from an IoT perspective around fleet management and preventative or predictive maintenance for service providers who are operating large fleets, not necessarily within the transportation industry, but have to manage large fleets as well. Within fleet management, we address a couple of other items which are really important to our customers, like driver attrition. It's really expensive to recruit and train drivers so you don't want them leaving. And to save costs, we focus on predicting driver incident risk in the terms of traffic violations or accidents. Those can turn into very costly expenditures for those companies to take on. Given our history in healthcare, which is part of where we got a lot of early traction at Prediction, in addition to some of the clinically oriented use cases of readmissions and length of stay, we do take a look at remote patient monitoring use cases. I mentioned before, this is really the opportunity to take a look at how do you provide better patient care and improve operations to bring costs down in remote patient monitoring environments. Today, there are about 2 million Americans wearing cardiac rhythm monitors that are monitoring, the condition of the heart, and being able to apply predictive analytics in that setting to make sure that we're providing the best quality of care with a tailored treatment plan is really critical to our customers. Last but not least here on the slide, we also offer a number of retail and marketing-oriented use cases. There's a lot of use cases where you need to provide effective segmentation and offer a recommendation based on real-time analytics for the next best offer. We also provide predictive lead scoring to help our customers understand what leads will most likely convert to an opportunity, which ultimately helps them generate more revenue. Now, assuming all of those challenges can be met, we need to be able to take a look at these challenges here on the slide. The interesting thing about the data from IoT is that the types of solutions that have been traditionally out there around predictive analytics are really not constructed to handle the volume or the speed of IoT data at the edge. And at the edge, many of those devices or machines are in very low bandwidth environments or are operating periodically disconnected. And that leads to a set of IoT architectures where data is often aggregated or filtered either at the device level or at an aggregation point, and that can create challenges with data blind spots and time lags. But when we talk with our customers, a lot of them talk to us about the need to perform these critical use cases with real-time actions performed at the edge. And in terms of taking action, we talked about those challenges. We need to be able to empower a diverse set of stakeholders to take action within a time frame relevant to what needs to be accomplished. What you see here is a framework for the types of decisions that need to be made within the IoT. This is a typical decision framework around operational, tactical, and strategic decisions. Operational decisions and actions are important to be made in very small time frames, often automatically, as in the case of performing an orderly shutdown to avoid things such as cascading failures. An example of an action to be taken within minutes to hours at the staff level is scheduling of an inpatient visit for someone who is showing an increased risk of worsening chronic condition. Examples of tactical decisions most often made at the managerial level include implementing an improvement program for a driver that is showing a higher risk of being involved in an accident, or scheduling vehicle maintenance a week out because the probability of failure of the braking system is significantly increasing over the next several weeks. Strategic decisions require a lot of time and data to support and are often made at an executive level. A decision to or to purchase manufacturing equipment to expand capacity, taking into consideration forecasting of things such as macroeconomic data at a geographical level, combined with asset utilization data at the plant level. And this helps to fine-tune purchasing made by more informed decisions armed with predictive analytics across multiple related data sources. So that really brings us to what prediction does. And prediction is really focused on providing real-time predictive analytics at the decision point to improve outcomes. We have a set of turnkey solutions built on top of our product called Prediction Insight. That really gives us the ability to bring in data from anywhere, whether it be sensor data, smart devices, static data like maintenance logs. We can bring that into our platform, analyze it, and create predictive models. The output of that process is really our secret sauce, and I'll talk a little bit more about that in another slide. But that thing is called an MLSM package, and this is part of what makes prediction really unique. That technology helps us to deploy that technology anywhere and really provide predict anywhere functionality for our customers so that they can take actions that are important to improve business outcomes. Sometimes we're putting those actions in the hands of, say, a clinician at the bedside. Sometimes we're generating alerts that may show up on a device that helps a field worker perform maintenance or perform an orderly shutdown to avoid some of those costs. But we also have a component within our platform called the Solution Accelerator, which can very rapidly be utilized to create applications to help generate all of those visualizations and insights from the predictive process and put that in the hands of people on the front line who can actually do something with it. We do at Prediction have a set of expert services around data science. A number of our customers often have questions for us where they may not have the right kind of staff to go through their data and identify those items that they want to solve or be able to identify some of those key influencers. We can help out with that as well. Sometimes there are data scientists on staff, and we're just augmenting their ability to work with our platform. We are all about providing these turnkey solutions, so our focus with data science services is really to help our customers, extract the most value out of the solution that we're providing to them, rather than just focus on data sciences as a service and a revenue stream for us. And we're all about, particularly in the context of IoT, providing analytics where you need it and when you need it. And this is really a key about what makes Prediction very different in our approach to the market. We're the only predictive analytics vendor that can run on the device, on the gateway, or in the cloud. So what you see here is a bit of an oversimplification of various IoT architectures overlaid with where we can actually run our predictive analytics engine. At the bottom level, we are really focused in terms of enabling that real-time insight and action to being able to run on-device and in real time, but also more importantly in connected and disconnected environments to help our customers deal with those scenarios where they're operating in low bandwidth and limited connectivity environments. If you do have an architecture that's based on a lot of sensors, that's often aggregated at some point on a gateway. We actually provide the ability to run our predictive analytics on the gateway when it's not feasible to run on the device or you do have those large sensor-based deployments. And actually, we actually put out some news today where we're working with Intel and Wind River on the next generation of Intel gateways. So really excited about that news, which further strengthens our position here. Last but not least, and a place where some customers start is really operating with a more traditional approach to analyzing centralized data in a cloud or data center. We provide that capability as well, but we are really unique in how we can run on the edge or at each level within an IoT architecture. So to give a little bit more details on our secret sauce, it's really around our patent-pending technology called the MLSM. That stands for the Machine Learning Semantic Model. And it provides a lot of value in terms of time to value during model creation, but also in deployment. So the typical steps for machine learning and predictive analytics is you bring in some data, you combine it, you do some data shaping, you work with various types of algorithms to ultimately determine what are the best in terms of accuracy or making sure you're clear on identifying what the rates of false positives or false negatives are. But ultimately, in our solution, the output of that is this thing called an MLSM package. We have a very intuitive tool set to be able to produce that MLSM package, but part of, again, what makes us very unique is our ability to run on very small footprint devices. So we do have an MLSM runtime that runs in .NET, but it's more popular to see Java environments within the IoT. That runtime is very small. It can operate in about a 1 megabyte footprint, which allows us to perform these predictive analytics on devices as small as something like a Raspberry Pi. So we've been able to show that we can execute predictive analytics on a 700 megahertz processor with 512 megabytes of memory running on a Java environment within an OSGI stack on a very small device, and really be able to provide that predictive insight, which we call the last mile of analytics. And that's really critical within the IoT because if you can perform predictive analytics in various places, it's only going to provide you so much value if you can take action on it. And part of what makes this really important, again, is running out on the edge. So I was having a discussion with one of our partners who described how this was going to be really critical for them to deploy our technology in a smart mining use case as an example. In an open strip mine, you have these extremely large, extremely expensive earth movers that are usually lined up one behind another. And if you have a failure of one of those trucks and it actually breaks down, you're not just stopping that one truck and making that one driver, less productive. You can be stopping all the trucks behind it because there's a limited area to move. You can actually stop the earth mover from filling up multiple of those trucks, moving the material out. It can even have a downstream effect in a very short amount of time and affecting drilling operations. And our partner was telling us that the solution that they had been taking a look at could identify the likelihood of something failing on a vehicle causing a breakdown. The challenge is within a field mining operation, that data did not make it to the cloud until 2 weeks. And it's pretty easy to see how, 2 weeks later, identifying a breakdown is not terribly useful. And that's one of the powers of not just predictive analytics relative to things like business intelligence, but again, being able to perform that predictive analytics on the edge, taking that vehicle out of service by the field mining manager out in the field before that data ever has to get transferred to the cloud will be very critical to making sure that mining production keeps going. So it provides us with a very unique set of capabilities that our technology is uniquely suited to handle. Now, in terms of connecting to the last mile from a user interface perspective, our platform and solution is very flexible in how we can help our customers work with that data. So going through just a couple of the visualizations here in the upper left-hand and in the upper center is an example of our solution accelerator technology, which provides rich visualizations to help you understand key influencers behind the actual predicted values so you can gain more insight into what was actually producing it, then connecting action to those predictions all within a single framework within the solution accelerator. We also provide rich integration capabilities for our cloud-based deployment. In the upper right, as an example, is a cloud-to-cloud-based integration with the Salesforce Wave Analytics platform where we're predictively enabling their application. In the lower left is a cloud-to-cloud-based integration where we're predictively enabling the Salesforce Sales Cloud for predictive lead scoring, all within a familiar user interface that sales and marketing operations professionals use on a day-to-day basis. In the lower center, this is an example of predictive maintenance for fleet management embedded in our partner's application. That was what I was referring to as Accenture's digitally connected products platform. And last but not least, in the lower right is an example of an end-to-end application we built for Carolina's health system for predicting the risk of readmission and associating that with interventions to reduce that risk. And that is an application that is deployed at the bedside for a clinician, such as a nurse, to take a look at and absorb that risk and be able to intervene with specific sets of actions that can help avoid that readmission risk. So what I'll do here is I'll walk the audience through a couple of very specific examples of predictive analytics in action. So the first example I'd like to share is on predictive maintenance in fleet management. This is an example that we have built jointly with Accenture to provide predictive analytics capabilities on top of their platform. I've talked about that a couple times in a presentation. We just showed you a visualization of that in the prior slide. What we were challenged with was predicting the need for vehicle maintenance based on predicting failure or performance degradation over varying time windows. As part of that solution, we trained our predictive model with the sensor data, including attributes like engine temperature, tire pressure, brake linings, etc., to produce that MLSM package that I talked about. That MLSM package was deployed into a CEP engine and execute a large number of predictions on the risk of failure in near real time, 1 month and 2 months out. Now, given this insight that we gave to our customers, they can take vehicles out of service if a failure is imminent to avoid things like non-delivery charges if they have perishable items or they go outside of the delivery time windows, or downstream delays due to unexpected breakdowns. fleet managers can also more optimally schedule maintenance that is actually needed given the predictive insights that we provide, and this helps them to better manage fleet capacity by keeping their vehicles in service and fully utilized. The next example I'd like to show is predictive maintenance for oil wells. So we actually implemented this project for a large oil and gas company that wanted to better manage their oil field operations. So they wanted us to show that we could predict component or system level failures and suboptimal operations on these oil wells out in the field. What we were able to do is produce models that predicted failures within 30 seconds, so we could help them perform an orderly shutdown to avoid cascading failures. We could also predict failure within 1 to 2 weeks out to help them better optimize field service operations for maintenance. And this gets back to some of the points that I made earlier. You know, avoiding a cascading failure where something that might turn into a small maintenance item can create a very large expense due to the asset itself, like a really expensive item like an oil well, or stop production, and that can have a revenue impact. And again, optimizing how you cluster service of oil wells out in the field. So you see the map here where we have identified multiple oil wells. If you can identify those time windows out, say 1 or 2 weeks, and you're going to have the need for maintenance on, say, 3 of those oil wells, sending a field service tech out to service 3 at a time in one shot versus doing that on a one-off basis as you're performing those typically reactively can help you save a lot of money in terms of maintenance. This example also showcases our ability to run on device directly on the oil well in this case. We were dealing with about 25,000 sensor readings per second, which produced around 2,400 or 2,500 predictions per second. So really bringing home that value proposition of being able to operate out on the edge. So in summary, you know, why is it that prediction software is really well suited to IoT and other solutions within predictive analytics? We've talked about how we can rapidly create value from your IoT data in terms of how we can analyze it and create those models. We're the only predictive analytics vendor that can run on the device, on the gateway, or in the cloud. So having that flexibility to operate in the mode to make those decisions and actions that's most important to you is really critical and is something that is described as a strength from our customers. They may choose to implement on one level of the IoT architecture or multiple, but having that flexibility is really key. If you need them, we do have those expert data scientists to help you gain insight and leverage from all that IoT data that's being generated from all these sensors and smart devices. And last but not least, we do have a proven ecosystem of technology and delivery partners. You know, as I discussed, you know, we have some great services partners and platform partners in terms of Accenture, a lot of great capabilities from our partner ecosystem. So with that, Eric, I'll turn it back to you, and we can get to the next portion of the session.
All righty, I'm taking back control right now. Let me go ahead and look here. And so let's bring in our very own, hold on one second, Dr. Robin Bloor. I'm going to hand the keys to you, actually. That's some pretty good stuff. So, Robin, you should now have this control. Okay, you're moving through the slides there.
I am indeed moving through the slides. I have found a button to push.
There you go. All right, the floor is yours.
Okay, thank you, Eric. I actually went through the prediction slides yesterday and had a look at what prediction was saying. It's been a while since I've been briefed by prediction. I was very interested to see that the presentation was entirely about IoT and the orientation of IoT. And I think that's very useful in a number of ways. I think it's very useful in the sense that we are moving into that world right now, and the more people talk about it, the better it is. And also, prediction has always been a leader in predictive analytics. So it's interesting to see how they find their position within the IoT. So basically, I'm skewing this presentation about the IoT really in response to Prediction's presentation. The picture here, by the way, is the Internet of Orbiting Things. all the satellites going around the Earth. I don't know who took that picture, to be honest, but in fact, I don't even know whether it's photoshopped, but there you go. I did find it out there on the web. The projections or the hype, I mean, people call it the Internet of Everything, rather than simply the Internet of Things, simply because it pulls everything together. Various estimations, 19 trillion of value, compound annual growth rate of 31.7%. You know, when you've got an economy that's growing at, you know, 3% at best, or worldwide maybe 4%, you know, to have something that's going at 31% is really quite extraordinary. The industrial internet has the potential to add 10 to 15 trillion of global GDP over the next 20 years. Things like that are, you know, rarely accurate, to be honest. But they're if you take the first three things together, you know, you're looking obviously at a very big, growing, the leading edge, if you like, of the world economy. I think GE is an interesting player in this because they're extremely large and they've got a finger in an awful lot of pies, and they see the convergence of machines, data, and analytics, and it creating a huge industry. Today, 14 billion objects connect to the internet, and industry analysts estimate it'll be between 20 and 100 billion by 2020. It could be a lot more, a lot less, depending upon where the low-hanging fruit is. The thing that I find most imponderable about this is that the really, really compelling Internet of Things for me is the health sector. And it's compelling because there are so many things that can be instrumented in the health sector, you know, to improve the efficiency of hospitals and everything that goes with health, but also to improve the outcome of pretty much all forms of treatment by putting the measurement devices all over people and having them regularly report. There was a project that it's called Mobile Warrior about. It's quite. I heard about it, you know, 10, 15 years ago. It's a long time ago, which was a U.S. Army project to try and put sensors all over soldiers so that it would know things like, you know, how much ammunition any individual soldier had, exactly where he was, exactly whether he had been injured, how serious his injury was. And one of the dynamics to that was the simple fact that if you have a soldier who's wounded in the field but not killed outright in the field, if you get medical assistance to him within 15 minutes, his chances of survival, his chances of staying alive are about 90%. And it's a curious thing because it's almost the same statistic for anybody that has a heart event, let's say, any kind of heart failure. If you get help within 15 minutes, then you're probably likely to come through it, and may be likely to come through it without being particularly damaged. So there's a very good reason to instrument people from a health perspective. So that's just the projections or the hype. This is a graph, and basically what this graph says is that the Internet of Things is going to be dominated by things. You know, it's basically instruments, everything that's around to get feedback, and all of these other categories, you know, personal computers, smartphones, tablets, connected smart TVs, smart entertainment devices, wearables, connected cars. They don't come anywhere close to the projections for the Internet of Things itself. So that's kind of an interesting thing, that there's going to be a vast amount of sensors of one sort or another put in all over the world. I'm really here, really repeating here what Prediction have already said, is that, you know, this is a multi-stage event-based architecture that the Internet of Things derives from. You know, there's a source point, and you could be doing processing at the source, and there are depot points where you're aggregating data or gathering data, and you could be processing there, and there's a central point, and you could be processing there, and there could be as many hierarchy, you know, as deep a hierarchy as you want, depending upon what it is that you're doing. And the point is that at every gathering point, you've aggregated together stuff that might allow you to calculate a threshold of some sort or another, and start pumping out threshold alerts to alert something somewhere that a given condition has arisen and therefore needs to be responded to. So, you know, you look at this and you think, well, this isn't the systems that we build traditionally. This is very unlike the systems we built traditionally. So when prediction starts to emphasize that it can probably function at most of the points in this kind of network, it's not a trivial claim. It could be a very useful thing if you need particular kinds of calculation done in particular places. The point that I like is that there are known apps and there are unknown apps, and the thing that's actually going on when we start to instrument the world is that we're starting to find out things that we didn't know before, and as soon as we start finding out things we didn't know, the possibility arises that whole new applications need to be built. So you're not only, if you like, gathering data that can be analyzed, but you really need to enable as much as possible analytical explorations. And the only thing that the data is probably not going to all arrive in the middle because there's just no point, especially when you start talking about exabytes. Really, you only are going to move aggregations about. You're not really going to move all the data about. And anyway, it's all connected, so you can go and look at the data if you really want to. I just thought I'd throw this in. It's just a point. This is to try and indicate how different a world we're moving into. We didn't, you know, in the old days when we processed transactions and we're interested in time, we used to timestamp things, but, you know, we didn't take the geographical location of when anything happened. Particularly, it wasn't often we did that, except we didn't take the virtual or logical location of where something happens because the network itself can be part of the system. We didn't record the source device. We don't know, you know, if you look at a transaction, you don't know which computer it actually came into existence on. We don't know the device ID even. If there are any actors, human beings involved in it, we don't necessarily naturally gather the information about actors. And, you know, if you take all of those 6 dimensions there, and they're not all single dimensions in actual fact, but if you take those 6 dimensions, that's the dimensions of event data. And that's just much different to what we had before. And the reason that I'm pointing this out is just to point out that we're moving into a different world when we move into the Internet of Things and event-based systems. It's bigger, if you like, than you thought it was. This is a conceptual point, and it's a point I've made before, but I kind of want to make it again. You know, the human being is, if you like, an information machine, and the human control systems, they work at different speeds. We've got almost instant reflex. That is, you know, the autonomic nervous system. And then you've got swift responses, which is actual physical reflexes. And then we've got the fact that we have a central brain and that we consider things and we respond possibly very slowly to certain situations. And we've definitely got 3 speeds in terms of what we do, and 2 of those speeds are almost real time, you know. And those 2, the reflex response and the swift response, are actually predictive analytics. We don't think of it this way. You know, you're looking at if you're looking at the computer screen now and seeing this particular slide, that isn't really what's happening. What's really happening is that inside your visual cortex, you're creating an image of what's happening in the outside world, and it's predicting what's going on there. And in actual fact, you aren't taking a full scan of all the information that's out there in what you perceive as the real world. You're taking very small scans, and the rest of you is filling it in using a predictive model. And, you know, there are various optical illusions that you can play on people, and it just points out the fact that in one way or another, what we're actually, our view of the world, our experience of reality indeed, is actually to a certain extent predictive. You know, and that puts a different slant in a way on predictive analytics, because a lot of what predictive analytics is doing is just alerting you to situations that need a response. Now, it might be doing some very sophisticated mathematical calculation to derive what it's doing, but actually our internal nervous system is doing an extraordinary amount of sophisticated calculation in order to build an image of the world. So, you know, these two things are not so far apart. And this tells me that in the long run, there will be predictive analytics in pretty much every organization, because every organization is gradually going to go towards an event-based world with fairly instant processing of data. So the Internet of Things can be thought of as internal, external nerve endings. You know, it could be, you know, the enteric nervous system that in one way or another is monitoring the organs of the body, or it can be, you know, the nerves on the skin that are taking information, or the eyes and ears that are taking in information. That's what we're moving towards, a kind of biological information processing world, or a biological model. And this is just to, you know, to emphasize the real-time aspect of this. Events are created in streams, and they're going to be processed in streams. Okay, I have questions to ask, but I thought, you know, I mean, normally I put a list of questions together to ask about things, but I prefer to ask questions on the presentation, you know. So I guess you would say that my first question is, I'd like to know more about this machine learning semantic model. It sounds very good. I mean, those are very nice words. When I think of machine learning techniques, there are a variety of techniques. I think I managed to list 19 once, but look at particular data situations, and in one way or another can do useful calculations for given situations. But that tells me what machine learning is, but it doesn't tell me what machine learning semantic model is. So could you expand on that for me?
Sure. So great question, Robin. So to give a little bit more detail in what we do on our platform, we provide the ability to encapsulate an end-to-end predictive modeling workflow within the MLSM. So as I mentioned, we bring the data in and we shape it. I'll talk a little bit more about the algorithms here. We provide native algorithms, and we've just recently implemented in our 4.5 release a couple of ensemble methods around things like decision force and boosted trees as a couple of the algorithms that are particularly well suited for taking advantage of the types of IoT data that are occurring out on the edge. And we can encapsulate that along with any transformation that you might want to create. So it can be something as simple as an aggregation of a particular attribute or signal that is a data source over a time frame of, say, 30 seconds. We can perform, obviously, more simple statistics like averages and standard deviations, but all of that can be encapsulated from how you bring the data in, the algorithms that you use to either predict the probability of an event occurring at some point in time in the future, or predicting the future value of some attribute at some time in the future. We have the ability to leverage our own native algorithms. We also provide the ability to ingest algorithms from R, so popular scripting language with data scientists, so that's a way of getting additional value from our platform by the investments that our customers have already made. And there's a number of algorithms that can be supported there, all sorts of different types of regression models, for example. That all can be encapsulated within the MLSM as well. We also provide the ability to ingest algorithms from Microsoft SQL Server analysis services. Within the platform, we provide the ability to compare the output of those so that you have the opportunity to select the algorithms that are best suited to your desired goal. Sometimes that's accuracy, sometimes that's minimizing false positives, things like that. But over time, the great thing about machine learning, which Eric talked about before, it's not really the concept of a robot getting smarter. It's just an algorithm that ultimately becomes better over time with the more data that you feed it. So within our solution, as you bring more data into the platform once the models have been created, you can continue to train that model and adjust the way that you react based on the improving accuracy, change the algorithm out, and then you can redeploy that MLSM package, which is a set of configurations that instructs the runtime that's out there on the edge how to operate on that incoming data. So that was a lot. Hopefully I answered your question. There might be
I thought it was very good, actually. If you could just add the following detail. Okay, let's say I've been, I've been convinced from, I don't know, from whatever I did, I've maybe tried your technology out in one way or another, and I've followed up references and so on and so forth. And I decide to implement. In terms of who is going to do the MLSM work, is that going to is that normally you provide some consultants that train us in how we would select various things, or if I already have active analysts, they'll kind of understand how they can do, how they can leverage this analytical work? Is that kind of how it is?
Actually, we're focused on provided more turnkey solutions. So again, alluding back to the announcement that we made in the press today, we actually have something called a predictive maintenance application. So what that is a set of predefined models and workflows where our customers can either retrain those models based on the specifics of their data. That process is fairly simple and something we can walk them through, or they can do it themselves, or work with one of our solution partners that we work with in terms of implementation. So we really are focused on doing what we can in packaging these end-to-end solutions and minimizing what the customers have to do in terms of getting involved. Now, if they choose to try to do something else that's beyond the boundaries of some of our prepackaged applications, then they can work with us, again, directly. It's something that we are really focused on being very efficient at in terms of delivering these solutions, or one of our solution partners. It is possible for our customers to leverage the solution themselves, but we find that when customers engage us, they have a business problem that they want to solve, and the way they solve it is with predictive analytics. And they often rely on us or one of our partners to help them get that problem solved in production as fastly as possible. But there are those customers who may choose to go and implement it themselves, but it's more often with us or one of our partners.
Okay, and assuming that, let's now think of me as a customer that's been around for like a year and a half, doing various stuff. Is the pattern that I'll normally come back to you and say, well, okay, we seem to have squared away this particular problem, this particular area of our operation, but I now have an idea that I could probably do the same, use the same technology to work on somewhere else of what we're doing. Is it a kind of land and expand thing that happens when you guys get brought into an organization? Is that what goes on?
That is a fairly common occurrence. So we can solve a wide variety of problems, and I talked about the use cases. And the example that you give is something very typical. So the one kind of conversation that we have that seems to have a snowball effect with our customers is they can quickly realize the value of, say, preventative maintenance or predictive maintenance within operating their fleet. But they very quickly then take a look at things like driver behavior. So they see the value of what we can do, and they get conceptually that predictive analytics helps them solve that problem in the way that they weren't sure that they could solve before. So then they often turn and say to us, hey, Prediction, can you help me understand better how to save costs around predicting issues that might occur with my driver? So that is a very common occurrence.
Okay. Well, just one more question before I hand you on to Eric, who will throw the audience at you. And you took the trouble to do a whole Internet of Things, and I know you could have done different slanted presentations. So I'm just kind of interested, just in terms of how much of this are you actually encountering? I mean, my personal, but it's always anecdotal in terms of an analyst and what an analyst sees. It does appear that the Internet of Things is starting to get very active. But, you know, what do you see? Roughly what, you know, percentage or what kind of feeling do you get for the growth of this market?
The growth is really significant. So, you know, the one chart that you showed, the device growth, that's one of the leading indicators that, you know, is very popular to talk about. But the reality is, once they're in for a little bit, they start generating this data. I'll characterize it this way. We have a particular focus on healthcare where we have a long and successful history, as well as, you know, our more recent focus within the IoT. Now, I would say at the end of last year, we were starting to see these engagements with our other focus, along with IoT, to be more 50-50. I would say, you know, a rough characterization, we're starting to see the engagements and inquiries. We're not seeing a slowdown on healthcare. In fact, it continues to grow at a very rapid rate. But in terms of engagements and the uniqueness of our technology and our message, it's getting more to be about, you know, 75% of the conversations that we're having today. So it's a good testament to, you know, you talked about hype on some of the statistics, and we get caught up in that a lot, but we are seeing, you know, real use cases that need to be applied to this IoT data, and we're seeing a really big uptick in our conversations as a result.
Okay, Eric, over to you.
Okay, good. We do have a couple of good questions here. So you had mentioned in your presentation something about how you can do analytics at the edge, and I love this concept. So you're talking about doing some level of analytical assessment out where the device is. Can you give us some examples of when that's a useful thing? Obviously, timing is a critical component in situations like that, but what's an example or two of doing that kind of analytics at the edge?
Yeah, so just to reiterate some of the examples, and I'll talk about some others, but in the oil well use case, the fact that you can predict out a component failure at 30 seconds, you really need to be able to do that at the edge. So between some of the items that I discussed, and, you know, Robin talked about some of the dynamics of data and the fact that data often gets aggregated, sometimes that can create data blind spots or time-lag blind spots. The reality is, if you don't perform an orderly shutdown on an extremely large and complex, expensive asset like an oil well out in the field within a very short amount of time, you know, less than a minute, if you don't initiate that, that can turn into literally hundreds of thousands of dollars or potentially even millions of dollars in damages or lost business due to the fact that you created cascading failures because you couldn't react fast enough. Particularly within, you know, large assets like manufacturing, as I mentioned, you know, oil and gas and energy, you know, those are very common occurrences where you have to take action quickly. And a lot of times those devices are operating disconnected or with limited bandwidth. So being able to take that real-time action on the edge is really critical in those use cases.
Okay, good. We have a question from an attendee, and this is a great question. Who typically installs the sensors and deals with the process of integrating those? Is it a third-party vendor? Do you guys get involved with that? What are some insights you can share in terms of who actually helps you set up the infrastructure to feed into a tool like Predixion?
Sure. There's a few elements to that. So what I'll start off by saying is that we are very much focused on the predictive analytics aspects. We fit very nicely and very uniquely into an IoT stack. We do have service provider partners that provide everything that you might need from end to end. So it's not unusual for an Accenture to do an assessment over an engagement that includes the original sensor installation, the architecture of the underlying data collection and connectivity architecture, then plugging us in to perform the analytics. That is one way that customers come to us, and that's more of a greenfield implementation. The other thing is, a lot of times these sensors have been in place for some time. In the case of utilities or manufacturing, there's been data in the M2M world coming off of these devices for some time, and the step has been with, again, like a partner like Intel, where they introduced the capability of having an aggregation point in a gateway. Intel and through their partner ecosystem can bring their gateway into that environment and provide a mechanism to collect that data to perform analysis and put it into the cloud. So it really depends on the type of engagement that your customers may need to go through. We can provide references within our ecosystem. It's not something that Predixion does in terms of setting up the sensors and the underlying architecture, but we do have an ecosystem set of partners who provide those capabilities.
Yeah, that's great. And I threw up this slide about this patent-pending MLSM, which is very interesting stuff. Robin obviously picked up on that. Machine Learning Semantic Model, if I recall correctly. And this is very interesting for a number of different reasons, one of which being that it can help companies shepherd the process, I suppose, of getting some value from this stuff. Because as you begin, if you are just new to using these kinds of technologies, odds are it's going to take a little while before you can get to some gritty details that can help you change your business. But with two things that you've talked about, it seems to me, one, the accelerators. I always love hearing about accelerators. I guarantee you customers always love hearing that companies have accelerators because it shows that you have identified a particular niche, you've spent some time optimizing or streamlining the process for serving that niche, and that's a very useful thing for, let's face it, people who are busy, and everyone out there in this industry is busy pretty much all the time from what I've seen. So that strikes me as very interesting, and the accelerators as well. Can you talk a bit more about the semantic model and how you're able to learn from certain customer engagements, like the oil well example, for example, and you're able to use what you've learned to help other companies in similar type positions, I'm guessing. Is that right?
It is, and that's the great benefit of the MLSM technology as well as the Predixion Insight product set from the platform itself to the solution accelerator. So in the case of, you mentioned the oil well example, when we go out and we learn the ins and outs of our customers' data and very rapidly produce one of these predictive models for them, there are a couple things that we get as a benefit. One, we can leverage that model in other engagements, and sometimes it is as simple as retraining a model that we created for one customer with data from a second customer, and that provides pretty quick time to value. You're not even creating the model from scratch. So that provides a great benefit. Sometimes you might have to tweak the model. So if you've actually created something, as an example, a regression model that predicts the likelihood of a failure of a component 30 seconds out based on the value that we're forecasting, that can be very similar depending on the category of asset. But as you might imagine, an oil well is very different from, say, a fleet truck. And conceptually, the same model underneath may apply, but those signals that generate that risk of failure may be different. And that can turn into simply a model tweaking exercise where you can go in, bring the MLSM into the Predixion Insight product, perform those tweaks very rapidly, and take a look at the results in a feature that we have called the accuracy chart, and then creating new fine-tunings from there. So the learnings that we have, to overuse one of the words, from our experience with working with some of our customers can very rapidly be applied to other customers within the same industry, or very quickly with some tweaks in other industries as well.
Yeah, sure. Well, it's okay to use words like learnings too much. At least you're not overusing words like robust and seamless. So
I'm trying not to. I'm a marketing guy, but I'm trying not to.
I'll try to give you lots of credit on that one. We have a couple other good questions here. We'll go a little bit long. Here's one around security. It seems to me that cybersecurity is obviously a very hot topic these days, and it strikes me that some of these machine learning algorithms can be pretty good at weeding out false positives. Is that something that you're focused on at all, security with predictive capabilities?
So we've actually started to look at prospective use cases driven by a number of our partners around security. The item about false positives, I'm going to speculate based on the question. So the types of questions our customers are asking us are, can you predict an attack? And attack can be a very general term, but in terms of predicting false positives, what you don't want to do is create an alert that has somebody shutting down a whole set of data set or infrastructure because an access pattern to an edge router looks a particular way unless you have extremely high confidence that that's what's really going on.
Right.
The great news about our platform is when we take a look at that historical data, one of the attributes of being able to take a look at the past is being able to show you, with the data that you have, the likelihood of false positives moving forward. So that gives you some confidence in the predictions that we have, and we can actually surface that information in, say, an end-user dashboard. That's usually going to show up like in a network operating center, network operations center in this particular kind of use case. So you're arming the people who are really going to take action with all of the data points that they need. You can choose to automate that, but if not, if you have a high degree of confidence that a particular, say, denial of service attack is going to occur, you're going to want to look at the false positives, and if that's 10%, you may be a little hesitant. If it's 50%, you're going to be a lot hesitant, but if it's 1%, you're going to move to take corrective action extremely quickly.
Yeah, right. That's a really good point. And, we have a number of questions here talking about different kinds of applications and what separates your technology from other players in the field. I guess I'll throw one over to you around web applications. There's a question very specifically about that. And I'm kind of guessing that maybe you're maintaining some kind of library over time as to what sensor data looks like from different kinds of very popular sensors, and I'm just guessing that's also true for web applications, maybe like very popular ones like Salesforce.com or maybe some more mission-critical ones. Is that true that you guys are kind of building up a library of what different sensors look like when they feed data in and kind of gaining some intelligence to get a bigger view of the overall picture of what's happening out there?
Sure. So there's a couple of different ways to look at that, and this actually is connected to the hot topic of data security in the IoT. So the good thing is when we create models, we don't necessarily have to retain detailed specifics about the underlying sensor. So the models can deal with anonymized data and continue to work across multiple industries, which is touching on the prior topic. So that doesn't become a challenge. In terms of collecting, what the characteristics of particular sensors are in particular environments, if we have the permission from our customers, we can certainly do that. But our customers own their data. We own the models, and our customers often share this with us because it helps them. It actually helps them to solve other problems, and they see the benefit of putting that out into a broader sense to help other customers learn from the data as well.
Okay, that's good stuff. Well, folks, we went about 8-9 minutes long here. I wanted to get to some of those other questions. We will forward all these questions on to our presenters today. Very big thank you to our friends at Predixion. They're chugging right along, doing some really cool stuff. This is a very hot space. You can rest assured there's going to be a lot of innovation in the world of predictive. And as I mentioned at the top of the hour, I love machine data because you can trust machine data 99 times out of 100, even more than that. So it's going to really help provide a nice, a nice tonic, I suppose, to strengthen our overall industry of trying to get value from data. So big thanks, of course, to our very own Robin Bloor, who served as the analyst today. We got a whole bunch more lined up for you this year, folks. We're filling in our last few slots for 2015. Send some information to us, info@insideanalysis.com, or send an email to yours truly. You can see we're on Innovators all month and SQL, Innovation, and Real-Time Data in August. And, of course, if you have any questions or comments, just email yours truly or hit me up on Twitter. And with that, folks, we're going to bid you farewell. Thanks again for your time and attention. We'll talk to you next week. Until then, take care. Bye-bye.